Okay, so it looks like the third question in this is like all about doing stuff in Excel. So it wouldn't really be good to do on something like this. So we'll just skip it. Just do question 4 then. So this one shouldn't be too bad. Although this looks like a long question. Let's draw this really quick. Put the graph in the same place. Keep it like kind of uniform. Right there. Water table. Another, Jesus, another one of these. That's where we just did one just like this. This is coarse sand. This is fine sand. And this is clay. We've got a height here, here, and here. It's 3 meters, 7.4 meters, and 2 meters. So what are we given? We are given that the void ratio is equal to 0.76 for the sand. We're not given it for the clay. GS of all soils is 2.7. And for the clay, I'll just put the clay here. And I can put the sand here as well. We have like one sand property. So for the clay, we're given that the compression index and the recompression index, has to be CC, is equal to 0.3. CR is equal to 0.05. And we are also given the delta sigma V is equal to 140 kPa. So the part 1 here, there's the question. Part 1 is the clay is normally consolidated with a water content of 43%. What are we asked? We're asked to estimate the consolidation settlement for the following 2 cases. So let's just draw this really quick. Goes down to like here. There we are. Gradual, steep, kind of like that. All right. So we're told for case 1, it's normally consolidated. So I'm assuming it's going to start here. We might have to do 2 of these. We're going to start here. We might do stack them, maybe. All right. And the water content is, let's just say part 1. I might be able to do the equations here then below for part 2, and then here. For part 1, water content equals 0.43, which is the same as 43%. Now, how does this help us? Got all these examples to look at. Probably this sheet is going to help us, and there should be one more example. These are all the different works. Here it is. It's the other example. I don't think this is the same kind of example, so it's... No, we're missing. We're definitely missing one. There should be two. Maybe there's just one in-class example. Nope. Alright, there goes the book. Here's the other one. I need a bigger desk, bro. I hate this small desk. It was not designed to do work on. It was designed to put a computer on and then do no work at all ever. It's so much paper everywhere. Oh my goodness. Yeah. Here's the other. No, that's not the other example. Here. It's time rate consolidation. Shoot. Yeah, so that's not going to help us. So now we're back down to this. Does water content appear anywhere here? Or what is water content used to find? This, it doesn't seem like a lab test. No, because it's got actual depth. Well, we can always just start doing the normal stuff. Water content of 43%. What does that mean? Does that mean instead of fully saturated, use a different level of saturation instead of what we're used to? Okay, so here we know it's going to be normally consolidated. We need to find a few things. Gamma dry, gamma sat, and gamma sat. So this is going to be, how did I do it last time? Like sand, clay. Okay. And going into this here, I believe we're going to use this because there's water content there. The other two don't use water content. So for this one, I'm assuming this is going to be the, instead of dry, it's actually going to be this. I'm not too sure actually. I guess not. The water content thing does freak me out though. I don't know where it plays a role. Doesn't look like it changes much. I'll ignore it, I guess. I ignored it last time. I'm looking at my homework now, and it's correct. Hmm. what's the difference if I do 2.7, like I'm just gonna try something real quick. 2.7 times 9.8 times 1 plus 0.43 over 1 plus 0.076, getting 35. Should I? It's not, it's 0.76, not 0.076. Okay, 21. That's a large, that is quite a large difference. Yeah. So we're just gonna do it normally then. And I'll ignore this because it looks like that's the correct thing to do. Look at the problem again. Just tried to slide off the table again. E-book. All right. So it's going to be G S times gamma W all over 1 plus E. For saturated, it's going to be gamma W GS plus E all over 1 plus E. And same for this right here. So let's just calculate these real quick. This is going to be 15.03. It's going to be like kilonewtons per meter squared. Here we're going to get 19.27. And for the clay, we don't know what E is. But we can probably find E for the clay, right? So if we assume saturation equals 1, we know George Washington, so GW, was born in the southeast. S equals 1. Water content equals 1 because it's fully saturated. Or no, this is where water content matters. It is too, this is. So here's where we put 0.43 times 0.43, 43% water content. All right, now we can get void ratio. And we can solve for saturation of the clay. So 2.7 times 0.43, 1.161. Sweet, so now we know the clay's void ratio. So we can solve for this right here. This is going to be 9.8 times 2.7 plus 1.161 all over 1 plus 1.161. I'm getting 17.5. Okay, we know it's normally consolidated, so we're going to have a start and a finish point right here. find initial vertical stress now. We're assuming it's going to be, it's the clay layer that's in question. So I'm going to draw it right there. So this is going to be oh man, not enough space. This is 122.85. We know delta V is 140, so now we know V final is equal to these two together, V0 plus delta V, which is 262. Wow, that snow falls hard, man. All right. So now what's SC? This should give us enough room to do the part 2. For NC to NC, H0 times CC, 1 plus E0 times log of BF, the initial. So that's going to be equal to coarse sand. I think this is all two-way, I mean. Coarse sand from the other problem right here. Sand that's a, you know, all two-way. So, or all one-way technically? I don't remember which one. Probably one-way. Two-way would be half. Yeah. Okay, so no, this is all one-way drainage. So this is going to be 2 meters times CC, which is 0.3. 1 plus E0, 1.161. All right, what's this now? Okay, I'm getting 0.0917 or times 1,000, 92 millimeter. So that's good. Now for the second part of this. So what did they tell us? Did they tell us anything about this? the clay is over consolidated with an OCR of, oh, hold on. Okay, sorry about that. Here is part 2. This is OC to OC, right? So that's going to be case 2. And the OCR ratio, let's see, they told us is 1.5. I can probably write it up here, kind of like how I was writing the water content for the other one. .38 means it'll change the void ratio here. It's going to be E1, E2. It's going to be 2.7 times 0.38. 1.026. And the OCR is going to be delta P over delta V0. So if we know the overconsolidation ratio, which is 1.5, multiply this by our initial stress, which will be changed because the clay set, this is going to be clay 1, clay set, clay 2. It's going to be the same thing, but we're changing what the void ratio is. Instead of 17, it's going to be 0.026. Which means this is 18.02 meters squared. And that just means that this last part for this is going to be 18.0, I guess. Be close, so it's actually 123. This whole thing for V0 is actually 123. Okay, so 1.5 times 123 equals the principal stress equals 185. So right here's 185. The initial is going to be here, which is 123, and the final is going to be this plus 140. It's going to be 263 over there. Okay, and now what is the SC for case 2? Here it is. This is going to be equal to H0, 1 plus E0, times CR, times log of V final, V initial. And the H, let's just plug all these in. Two meters times CR, which is 0.05. 1 plus E0, which is 1.026 times log of 263 over 123.368. And we are getting, oh shoot, that is so wrong. The wrong case. It's OC to NC? It's not OC to OC? Oh, it isn't. Because this is OC to OC. This is OC to NC. Because here is the OC part, here's the NC part, and it crosses both. So we just have to do a different SC equation. The rest of this is all fine. We just have to do the final equation differently. Duh, or as I should say, shpla. And then, like, just to show you guys briefly, this is the one we need right here. So I'm just going to start plugging that in. H0 is going to be 2, 1 plus E0, which is going to be 1.026 times CR, which is 0.05 log of P over V0. This could be 185 over 123. This is going to be like a rough estimate plus 0.3 because I'm rounding so much. Log of VF over P. So this is going to be 263 over 185. All right, and I'm getting roughly 0.054 times 1,000 times 1,000. I'm getting 54 millimeters. And that's also correct. So a little bit of a hiccup on the case version. This is case 3, I believe, right? Case 3 is OC to NC, yeah. So I'm going to call this one good, and this is the final part of consolidation. Which is homework number 8. And this isn't a problem number in the book, so I have nothing to write here. So, all right, there's everything for this, and I'm gonna just erase this, and I will write the correct one really quick. I know I did it because of laziness not to write it, but I feel like I should write it. That way I know how I got this. SC equals H0 1 plus E0 times CR log of P V0 plus CC times log final P. Ran out of space there. So there. I know I'm sure I'll know where to find this. It's going to be open note for the quiz, or final, actually, not even a quiz, for the final exam. Shouldn't call it a quiz. So yeah, there you go. So that's part 2 for consolidation. Hope you guys learned something.